Today's video is about the mobile gantry you have seen in a couple of the bus episodes. I thought you might enjoy seeing how I made the gantry and the decisions behind why it's the size it is. First up is the overall dimensions. I wanted to be able to move it in and out of the shed doors. I honestly don't remember how high the opening is, however when I look at the model I made in SketchUp, the overall height was 3.6 meters. So I assume it was something like 4 meters clearance. As for the width, from the outside of each wheel is 4.8 meters, and I remember the clearance is 5 meters. Why so many wheels? Why 8? Well, it just so happens I had a number of spare wheels and axles that came from portable silos. My dad had a number of these portable silos on the farm, allowing you to use a lever to raise and lower the silo so you could transport them around. He eventually installed them permanently in his seed business, so I collected these knowing they would come in use one day. Seeing as I had a few, I decided to use 2 wheels per corner to distribute the weight and also make them as a module that I could unbolt and remove if required. Lastly, I needed to know what size I-beam to use. I knew I wanted to over-engineer it, so I thought being able to lift 5 tons would be more than enough. My main reasoning is that I wanted to be confident using it when lifting really heavy stuff. With that in mind, I did a bunch of research using load-bearing calculators online, and I needed to get a 250 universal column. Being a specialty item, I had to buy a 9 meter length, even though I only needed 4.8 meters. As to the remaining steel, I used rectangular hollow section of 100mm by 50mm with a wall thickness of 4mm. With all of this, I went about designing it in SketchUp, using plenty of angles to ensure it was strong. You can see these top pieces look different. I was experimenting here with what position to put them in, and I chose a piece that connected to several sections. Now just to be clear, I'm not an engineer, but from looking at other designs and material used, I'm confident my design will be safe, especially seeing as I tend to over-engineer things. Now I also decided to purchase a metal bandsaw for my workshop, as my previous experience from cutting steel proved to me that it's not easy to be accurate, and the simple drop saws you buy aren't accurate either. So I made an investment and purchased this bandsaw as it allowed me to cut the size of steel at the angles I required. It's one of the best purchases I've made as it allows you to cut something accurately while doing something else. So I set about cutting up all the required steel sections and welding it together. I use a WIA 270C MIG welder, another great investment I made in the past. I borrowed a forklift to help me maneuver the pieces around as they are getting heavy and dangerous. Here are those separate wheel modules I made just sitting there for the camera. I've had the rims powder coated and purchased new tyres as the existing ones were all previous sizes and conditions. At this stage I spray painted the frames as most of the welding had been done, and it was going to be harder to paint the I-beam when it was positioned on top. I painted the entire I-beam as the section I cut off was going to be sitting outside and I didn't want it to rust away as it wasn't cheap. Once I cut the I-beam to length using an oxyacetylene torch, I positioned it in place using the forklift. After triple checking measurements, I welded the frame to the beam and also cut and welded the remaining support sections. A few more coats of paint later, I mounted the wheels to the frame, purchased a dolly for the I-beam, and the project is done. The block and tackle you see in this picture is one my dad gave me and is probably over 50 years old. I intend on purchasing one in the future that can take a lot more weight. I also have borrowed one from a friend occasionally, which is much better than the old one. So what exactly have I used it for since then? Here's it being used to remove the engine from the ACO 1810A truck. Jason pulling hard here, and here's me taking a pose with the end result. This was when I put the engine onto the back of a trailer so I could take it and get it pressure washed. Here I was moving pieces of old Holden FB and EK ute bodies into the back of the truck to store them. One thing I did find difficult was moving the gantry left and right when required. So I ended up purchasing these automotive dolly wheels. All I do is jack up the gantry, place these wheels underneath, and it's super simple to move the gantry wherever I need to. Here's a video where I had the truck engine and automatic transmission in the engine hoist, but I wanted to change the position it sat in on the hoist. So I was able to use the gantry to lift it up while I made the adjustments. From research, I believe the engine and transmission weigh about 800 kilograms. So this is one of these situations where my over-engineering gives me confidence that it will hold the weight. Finally, one last video showing how I use the gantry to move the engine stand into place. I had the stand on those automated dolly wheels as an easy way to move it about the workshop, but I wanted to truly demonstrate the gantry in action doing what I designed it for, lifting something up and being able to move the gantry at the same time. Thanks for hanging out, and I hope you enjoyed this video on my mobile gantry and the decision process that went into why it is designed the way it is. If you would have done it differently, then let me know your thoughts in the comments below. I hope you're doing well wherever you are, and until next time, bye!